Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on graphs of functions. Last time, you learned that a linear function takes the form of f of x equals ax plus b. You learned how to draw the graph of a linear function by completing a table of values and also by finding the x and y intercepts. In today's lesson, we will learn about quadratic functions, their graphs, and their properties. Are you ready, students? Let us begin. A quadratic function is similar to a linear function, but with some important differences. A function defined by f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0, is called a quadratic function. F of x equals 2x squared plus 5x plus 2 is an example of a quadratic function. A, the leading coefficient, equals 2. B equals 5, and C equals 2. Any function that can be reduced to the standard form quadratic function is called a quadratic function. For instance, f of x equals x plus 3 times x minus 3 can be expressed as f of x equals x squared minus 9. In this case, a equals 1, b equals 0, and c equals negative 9. Students, please construct a table of values for the quadratic function f of x equals x squared. You will use values of x that are between negative 3 and 3. Then, use the table to plot the points on the xy coordinate system.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, everyone. Your table of values should look like this one. What did you notice about the shape of your graph? It should appear like this. Instead of a straight line, the graph of a quadratic function is a curve known as a parabola. If we were to draw the graph of the quadratic function f of x equals negative x squared, the parabola would look like this. From these examples, we can observe several properties of the graphs of quadratic functions. The graph of the parabola is opened either upward or downward, depending on the sign of the coefficient of x squared. That is to say, if a is a negative value, the parabola will open downwards. If a is a positive value, the parabola will open upwards. Another point to note is that the graphs of quadratic functions are symmetrical. Also, there is a turning point on the graphs. The turning point is called the vertex of the parabola. The vertical line that passes through the vertex is called the axis of symmetry. Let us practice drawing some more graphs of quadratic functions. Students, please use a table of values to sketch the graphs of these two quadratic functions. Use values of x that are between -2 and 2, and plot the points on the same x-y coordinate system.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. What did you notice about the graphs that you drew? Both of the graphs are parabolas, and both open upward, but their vertices are in different locations. Also, the corresponding values of f of x equals 3x squared plus 1 are 1 unit more than the values of f of x equals 3x squared. From these observations, we can summarize the following about graphs of quadratic functions of the form f of x equals ax squared and f of x equals ax squared plus c. If the value of a is greater than 0, the graph opens upward. The vertex is 0, 0 for ax squared and 0, c for ax squared plus c. The domain is all real numbers. For ax squared, the range is y, such that y is greater than or equal to 0. For ax squared plus c, the range is y, such that y is greater than or equal to c. The vertical line that passes through the vertex is the axis of the parabola. If the value of a is less than 0, we can assume the following. The graph opens downward. The vertex is 0, 0 for ax squared and 0c for ax squared plus c. The domain is all real numbers. For ax squared, the range is y, such that y is less than or equal to 0. For ax squared plus c, the range is y, such that y is less than or equal to c. The vertical line that passes through the vertex is the axis of the parabola. Students, we have time for one more activity. Apply the rules you just learned to the function f of x equals negative 3x squared minus 2. Without constructing a table of values, determine the direction the parabola will open, the location of the vertex, and the domain and range of the function.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, everyone. I am sure you had no difficulty with this activity. In the function f of x equals negative 3x squared minus 2, the value of a is negative 3. Since this is less than 0, we know that the graph of the parabola will open downward. The value of c is negative 2. Therefore, the vertex will be at 0, negative 2. The domain is all real numbers. The range is all values of y, where y is less than or equal to negative 2. Were these your answers? Well done, students. Today, we learned about functions that take the form f of x equals ax squared plus bx plus c. We learned that these functions are called quadratic functions, and we discussed how to sketch their graphs based on their unique properties. In our next lesson, we will learn about the shifting rule, and we will study the minimum and maximum values of quadratic functions. Until then, thank you, teacher. Thank you, students.